The overall goal of this technique is to be able to quantify different metalloproteins in complex standards based on the use of known metalloprotein standards.
This method can answer key questions about the role of metals in biology. For example, how does the metal status of a protein change in disease? A key advantage of this technique is it allows you to measure the metal status of a protein in its native state. Demonstrating the technique will be Amber Lothian, a PhD student from my lab.
To begin, homogenize tissue or cell culture samples by manual dounce or sonication for 5 minutes using tris-buffered saline. Clarify homogenates by centrifugation at 16,000 times G for 5 minutes. After collecting the resulting supernatant, normalize the total amount of protein by determining the protein concentrations as described in the text protocol. Warm up and tune the inductively coupled plasma mass spectrometer using the manufacturer's protocols. Dilute the metalloprotein standards to ensure they fall within the range of 0 to 500 micrograms per liter using 1% nitric acid. To achieve standards within this range, do not use dilutions exceeding 1 in 20. Set up the order of injections by first analyzing the 7 calibration levels, concentrations ranging from 0 to 500 micrograms per liter, followed by the metalloprotein standards. The 7 calibration levels are 0, 1, 5, 10, 50, 100, and 500 micrograms per liter. Next, select elements of interest. Here, use iron, copper, zinc, cobalt, and iodine, as they are the elements that the protein standards are bound to.